Hey, so we have this word ratio we've been talking about. When we're using ratios, we're really just comparing two numbers. So we just compared black to orange kittens. And it really is a division problem, and you can write it three different ways. You can write it with a colon to separate them. You can just write it as a fraction, or you can say the word to, A to B. So it can be written as 5 to 4, 5:4, which we say 5 to 4, and they say the same thing, or 5/4, 5/4, 5 to 4. They all say the same thing, but notice every time the 5 came first, the 5 came first, the 5 came first. If it said that there were 5 blue marbles and 4 green marbles, blue came first, so we want to always keep it in that same order so that people reading the problem will understand that. So a ratio we can compare part to part, like we just did the black kittens to the orange kittens. We can compare parts to the wholes, so I could say there are this many orange kittens to the total kittens. Or we can do that backwards and say this is how many kittens there are, this is how many are orange. So all of these pieces are called terms. So let's do a little practice here. So we have a ratio of 6 oranges to 5 apples. So I want you to pause and see if you can write that in 3 different ways. So go ahead and do that and then come back and check. So I know oranges has to be first because that's what was given first. So I could say there are 6 oranges to 5 apples. I could say there are 6 oranges and just put the word to 5 apples. Or I could say there are 6 oranges to 5 apples. All of these mean the same thing, but notice I put oranges first every single time. Oranges came first to keep that ratio the same. So let's look at number 2 here. So Erin is making a quilt for a craft fair. The quilt is made with 4 different fabric colors as shown. So you can see blue, green, red, and white. So first we're going to draw a model to represent the blue squares to the white squares. So I want you just to count all of the blue squares and the white squares and see if you can draw some sort of model to represent that. There's lots of ways you could do that. So go ahead and do that. So I'm counting blue here, and I have 1, 2, 3 blue. So 1, 2, 3 blue. And then I've got white ones here. I'm going to use yellow to represent white. 1, 2, 3, 4, 5. So I could draw like a tape diagram and show 1, 2, 3, 4, 5. I could also just line those up and say there are 3 blue and there are 1, 2, 3, 4, 5 white. Either way, I'm showing 3 blues and 5 whites here. So we're going to write that ratio 3 different ways. So notice blue should come first compared to white. So see if you can write that ratio 3 different ways. So I know 3 blue, 5 white. 3 blue, 2 5 white, or 3 blue, 5 white. And now when I'm counting the total blue and white, I have 3 plus 5 equals 8. So there are 8 squares that are blue or white, 3 to 5 squares here. So now we're going to write a ratio statement that compares any one color to the total. So first, I just want you to pick a color. So maybe you're going to pick green or red or blue or white. I don't care which one you pick, and count that color of squares. And then you need to count all the individual squares, big and small. Each one counts as 1. And see if you can write a ratio statement. So that means you're just writing a sentence about the numbers of them. So go ahead and try that out. So I'm going to try red here. So I know I have 1, 2, 3, 4 red. So I could say there are 4 red for to a total of, let's see, now I need my total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, to a total of 15 squares. And I could do that same thing for the green. There are 1, 2, 3 green squares to a total of 15. So I can go through and do that for each one, but it wanted the single color first and the total second. So I could write that as a ratio and say 4 to 15, 4 to 15, or 4/15. Lots of ways to do the same information, a sentence, or 3 different ways to write a ratio. Okay, let's look at this problem here. So this says, for every large blue square, there are 2 small blue squares. So I have 1 large and 1, 2 small. So that sounds right. Every time I have 1 large one, there were 2 small ones. Does this mean that 1 out of every 2 blue squares is large? So this is saying if I have 1 big one, then I would also just have 1 small one. 1 out of 2 total is blue. But when I look at my picture, I have 1 big one and 2 small ones. So that means 1 out of every 1, 2, 3 is large. So this statement is not true. It would need to say 1 out of every 3 blue squares is large. So that statement was forgetting about, let me make that smaller. So this statement up here was forgetting about one of the blue squares. It was just saying 1, 2, but we've got 2 small ones, 1, 2, for 3 total. So let's see if we can go answer the questions on task 2 here. So here's just that model. So there are 8 total, 3 here, 5 here, 3 blue ones, and 5 white ones, which we drew a picture of. So now you're going to compare 3 to 5. Pick any of the statements that show blue first and white second. So you should be picking the 3 correct statements there. So every time we have a blue square, how many white squares? For every 3 blue squares, there are 5 white squares. And we can't simplify that anymore because 3 and 5 are already simplified. So now you're going to pick any that are true here. So it says select the statement. So anything that's true. So count the blue to the total, which we know was 15. The ratio of total squares to red. So total means there should be 15. So go ahead and see which of those are true. For every small green square, there are 2 large green squares. Let's see. 1 small, 2 big. So this says, does that mean that 1 out of every 2 small squares is green? So there are how many green squares? 1, 2, 3, and 1 of them is small. So 1 out of 3 should be small. Okay, so that is a little overview of rates and ratios. For the next several days, we're going to be exploring those deeper, looking at some different strategies, because there are lots of ways that you can get to the same answer. But we just need to understand that a ratio is telling us 2 things, and we can compare them 3 ways. And you can also compare part to part, whole to part, or part to whole. And you've got to read the statement to make sure you know which one should come first and what they're comparing. Hey, let me know if there's anything I can do to help you with this.